lay a foundation for what it takes to be a successful data scientist with lots of projects and hands-on exercises to build your confidence. Start your career as a data analyst. Sign up by visiting www.ftdatanet.ng. For more information, send us an email info@ftdatanet.ng or call us to 80 Data is the new oil in YouTube.
All right, you are all welcome. I hope you can see my screen. We're about to start. You are welcome to today's class. You are welcome. If you can see me, if you can see the screen, let me know. If you can't see the screen, let me know. You're all welcome, and I hope you can hear me. You can hear me. If you can hear me, let me know also.
I can hear you.
Okay, good, good, good. Now, if you can hear me, that means we can start. You're all welcome, and you're not going to take too much time. Today is R. Today is for R, and you know we started this out like 2 weeks ago or 3 weeks ago, thereabouts, and we've been talking about R. R is a data analysis tool. It falls in the category of tools like SPSS, SAS, and Excel. It has a combination of all those tools. It's a very fantastic tool, you know. And I think I've not sent the manual, but I will send this manual to all of you. This is the manual we're going to use in this class. We started, okay. So we started by talking about why you use R as a data scientist, and we mentioned some things in the previous class. Then we installed R. You know, we talked about what is R, why R, and introduction to R in the first class. So R is a very, very fantastic tool. So it's also programming, but this programming is not so complex. It's very simple to use, simple to learn, simple to apply to any given problem you have. And R works only on data. You can't use it to go and build a website. You can't use it to go and build a game. You can't use it to build robotics. It's strictly for data. It gets data and you use your code to analyze data, to work on data, to simplify data, to clean up data and all that, to restructure your data. So you are all welcome. And after that, we talked about why is it so important. I said that it can handle any kind of data you have. You see the first point here. No matter how big your data, even if your data is 4 million rows, you know, when I talk about rows, I'm referring to Excel rows now. Every one of us knows Microsoft Excel. So even if your data has lots of rows, millions of rows, how can handle it? What R does is it takes those data and start working on them, you know. And visualization is fantastic when it comes to R. Visualization is like one of the very best when it comes to R. R and Python, they do the same thing when it comes to data analysis. The same thing, they can do the same thing on your data. You see that you go for Python or you go for R. And if you have the time, you can do both, you know. They are both fantastic. And they are open source. It means R and Python are both free. You can, you know, some of us have downloaded it. Some of us have installed it on our laptop. And we can see. And because it's open source, it belongs to a community. So a lot of people contribute to this open source software. What I mean by the contribute is that R you downloaded could be R 3.6.1 point something. That is a version. That means a lot of people are contributing to this code to make it better, to make it efficient, to make it run with less speed, with faster speed and less usage of your memory. So these are some of the people that are working behind the scene. If you are very good too, you can contribute to the R community, you know. And a lot of big companies are using R, like Google, Mozilla, you know, I listed them all here. Then we talked about how to install R. R is very straightforward. Just go to the site. This was the site I gave all of us to install. You first of all need to download R. After you download R, you install it. Then you need to get the GUI. That GUI is the one that makes R easy to use, the graphical user interface. It's the graphical user interface that is on top of R. It doesn't come with R, but you download it and install it, and it's free, totally free. So this is R. When you install R, you see this view. But when you install the R Studio on top of R, you see this view. And I explained what all these segments do. This editor is where your codes are. The console, when you run your code, they are displayed here. This is where your graphs are being displayed. And this is where this workspace is where you put your data, any data that you use, any variable that is assigned to any data, it stores them here for you. So I'm going to send the manual. Then we went on by starting to use R. We talked about data type. What are the various data types? Because all your data needs to be stored on R. And how do you store your data? How do we represent our data in R? Our data are mostly alphabets and numbers, isn't it? We talk about that other part. The reason why I'm just trying to do a recap is for those of us that are joining for the very first time. So I'm trying to do a recap so that we get in the loop of what we've done in the past, so that we are not left behind. But as I said, if you are finding it difficult, you can always send me a WhatsApp. I will always be there to assist you, whether it's in the installation or running some codes and it's giving you errors. Even if the code gives you error, that's fine. That's very good. That's a good way to learn, because by the time you troubleshoot the errors and you get to know how to resolve the errors, then you have learned something new that I didn't teach you. And one thing about IT or programming, in any skill, is the more errors you get, and the more you are able to overcome those errors, the more better you become. All right. So we talk about data type. What is data type? You know, why do we need data type? What are the various ways of data type? How do we create data type? So data types are for storing. When we talk about data type, they are used for storing data, our data in R. That is what they do. They store our data in R. And we have the various data types. We have, because when you store your data in R, then you can perform anything you want to perform on it. You can do calculations, you can do any kind of calculations on your data. But first of all, R needs to have that data inside and stored as a data type. So I'm going to show us what we did last week. So I'm going to pull up my R Studio. Wow, this is my R Studio. Don't be confused. You know, I've explained that there are 4 components. The main component I want you to focus on is this first one. That is the place you type your code, your workspace. This is where you'll be typing your code. And you can see it has various menus, like any other software. It has various menus you can check out. It has the help, and it has this place where your data are being stored. Then this place where you run your code, this is where it is being run. So I'm going to just quickly run through data type. So last class, we talked about data type, and we said they are used for storing data. Like, for instance, if you look at the screen, I hope the screen is big enough. I hope the screen is big enough for you to see. I'm going to increase it. All right. So this is, I talked about number is another kind of data type. So if I look at this one, I said num. That num equals to 3.1. In R, when you are equating something to something, so that num that you see there, NUM, is a data type, and is storing the value 3.1. That means I've assigned 3.1 to num. So anytime I tell the computer what is 3.1? What is num? It will give me 3.1 because it has stored it. So that num, the data type, and what is storing is numeric. Any data type that has decimal points are called numeric data type. You will get it. The second one you see, KP. KP. And when you are equating in R, you don't use this. You use this and this. You get it? The arrow and hyphen. That's what you use. Use the arrow and the hyphen. That means you are equating something to something. Just like in math, you say x is equal to 2. X is equal to y. That means x is storing y. So that is what it means. That's when you are doing something is equal to something in R, you use this arrow and hyphen. Any value that is after the hyphen, it means is the one that is stored in the data type. So your data type could be anything. It could be Peter. Peter equals to 0, 0, 1, 0, 0, 0, 0. And it could be Peter equals to anything. 9 points. You see, anything you want. It could be a combination of any alphabet. But you cannot say 1 equals to 5. You know, you can't say. So when you are determining your data type must be alpha numeric. So I could say Peter 1 equals to 9. It will take it. But you can't just say a number is equal to a number, because that is not alpha numeric. So that is data type numeric. All right. Then we also talked about another data type called integer. Integers are data type that stores basically numbers without decimal points. So I could say ty is equals to 34. So automatically that ty is storing 34, and it is a integer data type because that 34 has no decimal point. That is an integer data type. Then the other one we discussed was I think we discussed, yeah, look at this one. Character. I said character 1 equals to learning how to respond. So you can see here, it's not numbers I'm equating it to. So what I'm saying, I put a quote and I put any form of text. Any text you can write inside. You can put space, you can, whether you like it or not, you can put space. You can remove the space. It could be without space. But this is this character 1 is storing a string. We call it string or character data type. So we know the difference between character data type, integer data type, and numeric data type. Then the last one we talk about, this is another one. I said me is equals to, and I wrote some rubbish there. You see? Then one thing I want you to also know is in R, anytime you see hash, this hash beginning any line, we have lines. You can see all the code is have lines. So if you see this line 22, there is an hash there, and there is, you can write anything after the hash. That means it's a comment. What it means is that you are making your code readable for people that are not the one that wrote the code to be able to understand your line of thought. So here, you will understand my code when I say I put a hash and I put anything here. I can write anything explaining num data type. It depends on you what you want to write. I can just say explaining the numeric data type using num. You see? So anytime you run the code, R will skip the comments. It normally ignores comments, but comments are for people so that anybody that sees the code will understand what you wrote underneath the comment or beside the comment. And the comment could also be even the place the code is. I can write it here. Explaining numeric data type. So it still performs the same function. You can put it anywhere as long as you start with an hash. I will ignore all these parts and run only this code. So how do we run our code in R? Very easy. You select your code and you press Ctrl Enter, or you see a run button here and you press run. And when you run your code, just look under here, you will see the code being run. So what you have said is you have told R to store 3.1. It has stored it. See, I've stored it for you. It's here. Let me run it again. You see, when I run it, it's the second time I'm running it. You can see it showing here. Then if you look at this place, that you can see that this place is for storing the data. So num is assigned to 3.1. But if I want to see what is inside num, I want to see the output. I want the computer to display to me what is inside num. I can just come here and type num and I run it, run that code. You see, it run it 3.1. That means row 1, 3.1. That means I am asking it display to me what is num, and it has displayed 3.1 for me. That means it's giving me back what I stored inside. So that is how you run your code in R. So we also talked about logical data type. Don't forget I mentioned 3. Logical data type deals with operators. For example, this one, I say y is equal to 34, z is equal to 50. And I say z is greater than y. Let's run this code and see what it will give us. I select all and I click run. So y is equal to 34. Yeah. Z is equal to 50. Then z is greater than y. It tells me false because z cannot be greater than y. Y is 34, y is z is 50. So it's supposed to be, the answer the computer gave us is false because 34 is not greater than 50. So this is the 4 basic types of data types that are in R. We have the numeric, we have the integer, we have the string or character, and we have the logical data type. Do we understand what we discussed so far? Or do you have questions before we move to another topic right away?
Well understood.
Hello?
Hello?
Okay, you were about explaining what you have under NII. I assume that should be Spring data type, right?
Under NII.
In front of NII, then some alphabets there.
Okay, NII, yeah, that's string data type. That I told you can write anything there. So all these from the beginning of the code, I think I just wrote a lot of random numbers. I just wrote random numbers. So this is a string data type. You can see it has symbols, it has punctuation mark and all that. The string data type. Then I can just another thing is those numeric data type, I could do some calculations on them. Right? I say NII is equal to 4.78. When I run that one, and I say NII times 2. I run it. You see, it gives me the answer 9.56. So it's going to, if I come back here and override whatever, I can come here and say NII equals to 5. And I say, give me NII. NII equals to 5. And I say NII. That means display NII for me. Do you think if you say give 9.56? No, it won't. That means I will override what is inside by 5. And I run it again. Now, and I say, give me NII now. And I run NII, I light it and run. You see, Ni is no more 9.56 because I'm overreading it with 5 using the code here. So what happens is the last R is a step by step. It runs it step by step. So even if you have declared Ni to be 10 up in line 10, and you come to line 50 and say Ni is equal to 20, it has overridden that Ni is equal to 10 in line 10. So that is one thing you should know about R. Do you understand it?
Yes.
Okay, so if you look at all what we've been doing so far, we've been storing values into data types, right? But those values are one values, you understand? But now I want to take us a step further. We are going to a topic called data structures. This is data structure. Let me go to the manual. So that's data type. Data structure. What is data structure? What is the data structure we talk about? We'll talk about vectors in this data structure. And how do we create them? Why are they important? And when do we use them? All right. So data structures are used to store and organize data, just like data type. But one good thing with data structure is that they can store multiple data types. You know, we have just single data. I told you about single data types when I said Ni is equals to 4, Ni is equals to this, Ni is equals to learning how to respond. You can see that it's only storing one data at a particular time. But data structure can store multiple data to just one variable, to just one data. So that's why I said it composed of multiple data types. For example, when we say name contains Bob, Alice, Ruby, and Alex. Age contains this. This score contains this. So you can see this name is storing 4 values. Age is storing 4 values. Score is also storing 4 values. And this one is what? String, integer, and numeric. Numeric because it has decimal points. And this is how, that is why you can see that data types are much more powerful than data structure are more powerful than data type because you can store a lot of things. And in R, you'll be storing a lot of data sets, a lot of data. So you want something that can store large data for you. That is when you use data structure. And there are different types of data structure in R. We are going to focus on vectors tonight. We are going to focus on vector. Vector is another data structure. One good thing about vector is that it stores data types of the same class. So if you are storing numbers, you stick with numbers. If you are storing, yes, all elements in a vector need to be the same data type. For example, age, that's 22, 20, 19, 23. And you declare another vector and you say age is equal to 22, Bob, now this is wrong. It won't take it. So if you're going to just stick to whether you are storing alphabets or you are storing numbers. All right. And I'm just going to go straight into R and show us data structures. Good. So this is my screen. I've written my code so I don't waste time typing it all over. I can send the code to you. So data structure class. You can see I put my comment. So we're going to create a vector today. So this is how to create a vector. When you want to create a vector, it has the left-hand side and the right-hand side. The left-hand side is before the equals to. The right-hand side is after the equals to. So this is the left-hand side, and this is the right-hand side. All right. And there's an equals to here, as we know earlier. So if you look at the screen very well, I named my vector. You can give it any name, anything you like. It's not compulsory, it must be vector. You can call it Kemi, you can call it Tayo, you can call it Ball, you can call it P, you can call it anything. Just make sure it's not number. It can be alphanumeric. So I said my vector 1 equals to, when you are declaring a vector, there is something we call this C you are seeing here. It's not just C, but that's a function it's doing there. That's a function. But that function is called C operator or concatenate. C operator, you can see my comment here. C operator or concatenate. So it allows you to, if you don't put it there, it won't work. So you need to put that C there. Then you can declare your numbers. Now, this my vector is storing 4 numbers, 9, 8, and you put a comma after each number you are storing. 9, 8, 2, 7, comma. So that means I've assigned all those 4 numbers to vector 1. How do I run it? The same way we run our code. I'll come here, select it, run it. So if you look at this place now, I've run my code. I just told the computer to store vector 1 to contain this. Then if you look at here also, vector 1 on the right hand side, vector 1 is storing 4 values. This 1 to 4 means it's storing 4 values. R has calculated that, oh, I'm seeing 4 values. So that's why you see 1-4. And it also displays the value 9, 8, 2, 7. All right. And the next thing I do is I click on that vector 1 and I run. So when you see a name of a data type being typed alone, that means, and you run it, that means it's going to display what it contains when you run it. So when I run this one, you see, come here, you see, that display the output for me. It displays what it contains, 9827. All right. Do you understand how to create a vector now? We will start using them. When we start using them, when you have an Excel sheet and you import it into Excel, you need to store the values as vectors. That's when you appreciate the beauty of vectors in R. That's when you appreciate it better. All right. Then vectors in line 7, I say vectors take only one data type. So look at this, my code here, line 8. I created a new vector, vector 2. And I did something funny. And I put alphabet there, Bob. You can see the Bob in between the numbers. And you know, I told you that when you are declaring a vector, all the elements must be the same category. You can't put numbers and put alphabets. So when I run this code now, it's supposed to give an error, right? But let me run it and let's see. It went through. See, this is it here. That stored it. But something funny has happened. When I say, okay, give me the output of vector 2 and I run it. Now, something funny has happened here. If you look at the output, it's just one row. This one means one row. This one in quotes, in brackets. So you can see that it has given all the numbers quotes. 1 is in quotes, 2 is in quotes, 5 is in quotes, everything is in quotes, Bob is in quotes, and 1 is in quotes, 9 is in quotes. What R did was, R converted all my numbers to alphabet. So these numbers, there are no more numbers. Anytime you see a number in programming, in quotes, it is not number anymore. It is now a string. A string is like an alphabet. So it has converted it to alphabet. So you can't say that number times 2. You can't multiply by 2. You can't perform any mathematical computation on it anymore. You understand? So what R did was, R was confused. So he just converted everything to numbers. That is why you see everything in quotes. Do you understand that area? So what I'm going to do now is, I'm going to override what is in that vector 2. I override it with this and I run it. Now, vector 2, when I run vector 2 now, what do you think will be inside? It has changed the value from all this long one to this now. You remember I told you that in R, line matters. Where your line of code is matters. So it has overridden the value here to this now. That's what you see here. Then we can perform mathematical or arithmetic computation on vectors. Like you can say vector 1 plus vector 2, vector 1 minus vector 2, vector 1 divided by vector 2, vector 1 multiplied by vector 2, or vector 1 plus, yeah. So what will happen here is, when you say vector 1 plus vector 2, what R will do is, vector 1, if you say is 9, right? And look at vector 2, 1. So it will add 9 plus 1, then 8 plus 2, then 2 plus 8, 3, 5, 3, then 7 plus 8. So let me run vector 1 plus vector 2. You see, it gave me the output. So what it is doing, 10, 10, 5, 15, which is correct. It will add every corresponding element in the vector together. So 9 is the first element here. Then 1 is the first element in vector 2. It adds them together, it gives us 10. 8 is the first element here, and 2 is the first element here. It gives us 10. Like that, like that. And I can do the same thing. Vector 1 minus vector 2, and I run it. See, it gives me an output here. Vector 1 times vector 2, I run the code. You can see, it gives me an output. So you can see, you can perform mathematical computation on vectors, just like I just did for you to see in the screen. So, if you look at line 20, I'm telling this vector 1 to be added with 1, 2, 3. This is a new vector. But this vector 1, remember it has 4 elements. Let me try and run this code and you will see an error. See, when you see red in R, it means there's an error. When you see your code displaying in red, it's telling you there's an error. In vector 1, longer object length is not a multiple of shorter object length. Basically, what it's telling us is that this vector has just 3 elements. And I'm trying to add it with a vector that has 4 elements. It's not going to work. That was why you saw that error. You know, when you're working with vectors, all the elements have to be the same. The number of elements. So if there are 4 here, there will be 4 in the next one. If there's 5 here, there will be 5 in the next one. All right. So another calculation we can do, we can even do more than all these ones. These ones are simple ones. Look, here, I have a vector, my vector, and I have its elements in it. And I have another data type, I have it in it. And I have my vector 2. I now did some calculation. If you look at the screen very well, you can see that I'm performing serious calculation on this, my vector 2. So my vector 2 is a vector, obviously. You can see the C there. It has elements. But look at this place. This is 6. Okay, I need to explain this one. This is 64 raised to power 0.5. This is how you type raised to power in R, comma. Then I said this one, this is another element. 2 plus 3 minus 1.1 divided by 9.44, comma. Then 4. 4 is what? Who knows what 4 is? What do you think will be represented by 4 here? Who can answer that?
32.1.
Correct. So what R will do is if you look for 4 and put 32.1 here. So if I run this code now, let me run it. Okay, I've not run the. Okay, you see, it gave me an error. 4 not found. The reason is because I've not run the code for 4 and my vector. So I need to run these 2 first. Then if I run my vector 2 now, it should work. Yes. Then if I say, give me the output of vector 2, see, it gave me the output. It did the calculation for me, and it gave me the output. Yeah. So even if I remove all these things that I wrote here that are just long things, you can, if you want to know the value of that one, just copy it and run it separately here. Let me just run it separately. So that's 2 minus 3 minus 1, bracket 3 minus 1, that's the answer. This is the answer here for that one only. And that's why you see it here. Then this 64 raised to power, this 64 raised to power 0.5, you can know the answer if you just run it separately. Let me just copy and run it separately here. So it's 8. 64 raised to power 0.5 is 8. That's why we see 8 here. All right. So that is the element of my vector. Then look at combination of vectors. I created another vector 3 here. And I said that that vector 3 should be my vector, comma, and my vector 2. So what do you think will happen in this situation? It will store all the elements, right? So let me run it. It will store all the elements of my vector and vector 2. And I say my vector 3 now. See, it has stored all the elements of my vector and my vector 2. These are all the elements. It combined them together. Do we get it? Do we get it? My vector 1 has how many elements? 1, 2, 3. This is my vector 1. Look at line 23. This is my vector 1. You can look at the code. They are there too. We have 1 here. We have 3 here. We have 1 here. We have 42. Then my vector 3 has these elements. And they are all here too. So that's how to do that. All right.
Sorry, I'm wondering why
Can I ask
it's
you
having like decimal, is in decimal form.
6 decimal places. That's my question. What function did we give?
Why is having decimal points?
6 decimal places.
Yes, because of the exponential that was in this vector 2. That's why, you know, this vector 2 has 1 raised to power 0.3. And it has 64 raised to power. So because of this exponential, if I didn't put this exponential here, if it was just ordinary number, all your output will be in ordinary numbers. But because of this one exponential 3, that is why it's making everything to be in decimal points. Do you get it?
Okay, thank you.
So because of that, it altered everything. As long as you are using vector 2 with any vector, it will alter it. That is why it's affecting everything. All right. Then how do you know the length of your vector? There's a function called length. It will just tell you the length of the vector. How many, if you count the elements and tell you it won't tell you the elements, but it will tell you the length. Like if I declare DE to be length, that's the thing, then you put the vector name inside. So if I run this now, okay, my vector 4 not found. Okay, let me declare vector 4. Then I say length, D is equals to, then I say what is DE? So DE has 10 elements, and it's true. If you count it, there are 10. 1, 2, 3, 4, like this. It tells you the length of vector. All right, indexing. So supposing you want to access a particular element in that vector, how do you point to it? How do you change it? How do you change that element? Maybe there is 2 in one of those elements. I want to change it to 5. How do you do that? That is called, you use indexing to do that in vectors. So if you look at this one, vector 1, and I put 3 in this close bracket, it means it's going to look for the third. You are telling R to look for the third element in vector 1. If I run this code now, I hope I've run vector 1. All right, it's telling me that the third element in vector 1 is 2, and it's true. You go and look at vector 1. This is vector 1, 9. Oh, if you change this. Yeah, it's correct. The third element is 2. 1, 2, 3, 4. This is the fourth element, second element, third element, and fourth element. So the third element in vector 1 is, the third element is 2. So it's correct. It gives us 2. So that is how indexing works in vector. Then if you say, and you put a minus, that means you are telling the vector to omit the second element in that vector. You understand? So when you create a new vector now, and you say omit the second element in vector 1, that means it's going to omit 8, isn't it? So I'm going to run this one. Let me run this code. So whenever you see minus in a, let me run it. Then let me see, display the output of new vector. So you can see my output now. You can see 8 is not there. It will omit the second element. So what if I put V10? What do you think will happen? See this one I highlighted, vector 1, and I put 10 in brackets. What will be the output?
0. We don't have 10. The numbers there are not up to 10.
Up to 10, yeah. It won't give anything.
So it's out of boundary, right? Let me run it and see. It said not available. Not available because it's not up to 10 elements we have. All right. So I will send you this code so that you can run them on your own. Then, for instance, there could be a situation where you want to declare a long list of numbers and you don't want to type them. Let's say you want to declare 1 to 100 and you don't need to type them. You type 1, 2, 3, 4 in your vector. We can use something we call using the operator hyphen. You see it. So we can say age is equals to 1 dot this, and I run it. Then I declare age, run it. I want to see the output of age. You see? So instead of me typing, I just put 1-100. You understand? So it declares everything for me. You know, this is row 1. It does 1, 2, 3, like that, 30, like that, like that. So that's how to declare a long list of numbers. Then, for instance, you could also want to create sequence. You might want to generate 1, 3, 5, 7, like that, like that, like that, to a particular number. We use what we call sequence. Like this sequence is a function. So you are telling it to start at 1, stop at 101, but skip every 2. At every 2, So when you say 1, 3, 5, odd numbers, you understand? So let me run the code. Then I say I want to see age. You see, it's only the odd numbers it brought out for me. You can change the sequence to anything you like. Maybe every 10. Then you stop at, let's say, 1,000. And you run it again.
1, 10, 20, 30.
So you see? So we're going to stop here today. Have we learned anything different or new?
Definitely we have. Oh, we that we
Yes.
don't have background of programming, we'll go and start
we
looking
have.
at it and start assessing and start digesting
In
it.
fact,
But you that have the what's it called now, the background, you might not find it so. It's okay now. I'm getting it. I think I'm getting it. But my question is, I could see
you're
some
getting
letters.
along.
Can you hear me?
Thank you.
Yes, I can.
I could see some writing in green. I guess you wrote it there yourself, or is it the app that gave that those what's it called, comments, or you wrote it?
I wrote it
Yeah,
myself.
comment.
I wrote
Okay.
it because of the class.
Now I understand. Just to teach us.
Yeah, just.
Okay. I just wanted to know now.
Okay.
So what
I wrote
else?
it. Okay, you said something that you don't have knowledge of.
Yes, I don't. But at least I'm trying to process it, and I think I'm getting it. So if we have the manual now, it will be so easy for us to go over it and over it. When we are used to it, then it becomes part of us. If we will make use of it,
Okay.
we need it.
We will.
You are scientists now. You are data scientists now, Abby. It is where.
We're all learning.
Okay. Oh, I thought maybe that's Adenike.
So what I can do is I can send these codes to you. Have you all installed
Okay.
the R on our laptop?
I have it.
Okay. Has
Yes.
anybody else installed the R on their laptop?
Yes. I have
Apart
it.
from Bumije. Has anybody else
Excellent.
installed R on their laptop? I think
Yes.
it's only Bumije and Excellence that have installed it. What about Temi, Sunday, Dotun? Well, one thing about R and Python is they are tools, especially if you want to go into machine learning, artificial intelligence, you will need to know one of them. That's all the truth. You need to know one of them. I'm sure you've heard about it before, Python R, and this is the R they are talking about. This is the powerful R they are talking about. These ones we are doing is still child's play. It's child's play.
Hey, if this is child's play, so what are we expecting?
Eh?
I'm just commenting now.
It's child's play. It's still...
I agree now.
Okay, please, I have a question.
Okay.
Okay, line 8. Let's assume that that string Bob there, let's assume is not in quotes. How would how would the output look like? Because I'm trying to compare it to line 25, where you are making reference to FOO, in which you've declared FOO as 32.1 initially. Let's now assume that in this case, we've not declared Bob as anything, but probably we forgot to put Bob in quotes to make the R or interpret it as a string. So what would the output look like?
Good question. Let me try it. But it will tell you, I don't know Bob because you have not declared Bob earlier. So let me run it.
Okay.
But that's what, let me run. You see error, object Bob not found.
Not found. Okay.
Because there's nowhere we've declared Bob up.
Bob. Okay.
We've not declared Bob up in the previous code up. But this one, the reason why we didn't get error is because we've already knew that, oh, you have declared it here. So you pick what is inside there, substitute it for full. Actually, I could have written 32.1 inside, but I just decided to write that inside. So I think it's not about cramming the codes. I think it's more about trying to practice and do other computations yourself, you know. And if you start practicing some, maybe I should give you some exercise. If you start practicing some exercise yourself, then you will understand how to use it. I know a lot of you might not use it when you are working right now, but there's nothing bad in getting a new skill. You don't know where you will need it. So tomorrow we'll start we'll continue our Power BI class, 7 p.m. or 4 p.m. Maybe between 4 or 7. I will ask us to vote for tomorrow soon, so that we will know whether it's going to be 4 p.m. or 7 p.m. Tomorrow is a Saturday. And I will send the code. I want you to run the code that I will send my code to you. I will just send the file. So once you get the file, just highlight it and run it. When you double click on the file, it will open it with R for you anyway. And highlight the one you want to run and click on run, and you see how the outputs are being generated also. Then try to change some values there, change the arithmetic there, change it to your taste, and see whether it's still getting you something sensible, whether it's not giving you error. Change the values. Like, for example, you can change this one here, the arithmetic here. You can change the arithmetic, the mathematics here. You can change all sorts. Just change it and see whether it will give you the value that you are expecting. So thank you so much for your time. I hope it was not too boring. So we'll see tomorrow. We'll continue Power BI. Thank you so much, and have a wonderful.
So when do we expect the manual, and what you want to send to us?
I'll send it now. I'll send it now.
Yeah, and I'm here to get the manual for Power BI.
We sent it now. Everybody has that one.
Okay, when next will be our class?
Oh, you know, my first class was Wednesday. They told us to drop our email address.
Oh, you didn't get it. Okay, I guess you are the only one that's who is talking now?
It's for the new set, okay.
Okay. Oh, you didn't get it. Okay, I will send it.
Okay, thank you.
Yes. All right.
Okay.
Thank you so much for your time. I will send this one now. Then I will send the Power BI afterwards. All right. Have a wonderful evening. Thanks for sharing your time with us.
Thank you, sir.
Bye-bye.